Hello everyone, it's Ben Diger. I'm going to be doing some streaming today. Um, we're going to start off talking about what happened last night with my vacuum former that I was working on building. So this here is the base plate for the vacuum former. Right in the middle is where the vacuum hose goes, and there's a PVC pipe. This is after the base plate has had wood attached to separate the particle board, which is in this shot, which is blurry. I apologize. I'll move to this one. And then all the holes around it are sealed up so that when I put a sheet of plastic in the oven, it goes on top, and turn the vacuum on before you put it on top, and it pulls plastic around. Basically, how they make action figure cases and whatnot. So I did this last night, and I jumped ahead too far. And some unfortunate things happened, especially with my computer at the moment. Okay, so put it on, and this plastic I got for free from Alpha Plastics, which is in Coon Rapids in Minnesota. And they were generous enough to give me some free plastic because they were wary about vacuum forming the mold that I brought to them. And these holes happened, and this is because the plastic doesn't stretch very well. It wasn't exactly the plastic that I should be using for vacuum forming. It was a little bit on the thick side, but it wasn't too bad. These holes, when they popped, sounded like gunshots. This is the one that was the loudest, and this happened because I have a huge hole here, so the part's not flat. And because the part's not flat, the plastic will go in there and kind of bow in until the plastic stretches to the point where it loses its ability to maintain its integrity, and it pops. And this caused the rest of the mold to not really mold well. And some other holes happened because I was plugging up the other hole and trying to get it to suction down. What happened last night? I did get a actual mold out of it. I used the heat gun and kind of finished up the job, but it did a better job than my previous attempts with a heat gun and molding the plastic manually. Plastic has to go somewhere, and I couldn't stretch it by hand. A lot of the heat gun attempts failed, but this is the best one yet. I'm actually going to work on 3D printing parts to make my mold better, and then I will re-vacuum form with the plastic I get from Amazon, which it should get here tomorrow, so I'll be able to post some photos for that. It does fit well. It matches up correctly. I'm hoping the vacuum form on Saturday works a lot better. So we're going to get started. We're going to remake this. I'll also have to sand out my mold and make it as smooth as I can get it. I'll probably paint it with some glossy paint and get it to not show so much of the detail, so it won't look as foggy or as unclear as the plastic is, because the plastic before it's molded is quite clear. So let's get started. I have actually made a helmet that's going to be uploaded, and this is the A, so I'm not going to be working on that one. I will come back to it and do the same stuff that we're doing today. I will be the parts very soon. For those who've been waiting, I apologize. I wanted to have it all up there rather than doing one part at a time and having people wait for the parts there. So I'll post this live when it's ready. It is close to being done. I just want to have these molding parts ready so that it's a one-stop shop. You can print all the parts and make your own helmet. Hopefully within a couple of weeks. It does take a while to print the helmet. So let's get started in Maya. I'll just pop to Maya if I can actually find it. I have a lot of stuff minimized. So this is where we left off. I have the electronic parts. So this is where we left off last time with the electronic mount. I have yet to print it because I wanted to get the visor done so I know where things need to line up before I finalize this and upload that. So we're going to go ahead and hide all the parts we don't need, and we're going to start working on the helmet design, or not the helmet design, the visor design, to fill in this gap between the top and the bottom. So basically this half shell that's right here, we're going to attempt to fix that. Let me just click that up. There we go. So we'll hide our parts and get started. I'm going to try to talk a little bit less this time, unless questions, if and when people actually start watching the stream. So far nobody's jumped on yet. There were 2 people watching before the stream started, but who knows. I'm going to hide my mounts, or I'll keep them there. So to select all the parts, and I'm going to group them together so that I can come back to that original position. And I'm going to move to my side view so I can get this lined up with the black. Rotate it. So this is the way it looks when it's on the vacuum former. So the back and the front and the back, or top and the bottom, line up with the vacuum former when it's laying flat. And this is where the problem happens. There's this big open space in the middle and on the front over here area. This needs to be smoothed out so the plastic doesn't bend and stretch into directions that are going to be difficult for it to do without popping or ripping, I guess. So we're going to line this up in the black line. Doesn't need to be perfect because this is just the mold, and I'm going to do the rest of the work later. So we're going to make a shape that will fit to fill that gap, and then we'll make a part that fits up here. I'm not going to so much worry about the front over here, because if I zoom in, it does lift up a little bit. But when the part is flat on the bed, it is flat enough that I want plastic to actually kind of bend into that direction. So I'm not going to make this be smooth with the ground. I'm actually put in a flat plane here so you can see what I'm actually doing. And I'll put some grid on it so we can see it. Polyplane. Okay, polyplane. So let's put a 20 by 20 grid. That way we can actually see it. So let's pretend this is our bed that we're going to be printing on. And we need to fill in this area here and this area here. And I'm just going to make some sloped parts that will kind of interlock on the inside that I can glue in, because I do want to have a seam there that I know that so I know where to cut it. So I can cut the shell out. I will probably upload a version of this that people can bring to an actual vacuum former that will be fully 3D printed from the top to the bottom. To save on plastic, I'll design it so that 2x4s go inside. So there'll be one that goes across left to right, the short one inside, and then there'll be one that goes from top to bottom below that, just to kind of fill all that space so that when this gets dropped on top of 2x4s, you can glue them to that, and then you can make a nice solid mold that's not going to collapse under the very high pressure of a vacuum former. Your shop vac or home vacuum cleaner isn't really going to give you the suction that you need for vacuum forming, compared to, I mean, it'll work, but compared to what you'll get at a vacuum former, an actual company that does it, I think it's like, what, 18 to 20, or no, it's 12 to 18 inches of mercury, whereas your vacuum only does about 4 to 6. I'm just trying to remember what I've been told about that. If you really want to know what the actual amount is, Google it. Because I'm going to start with the front part right here, because that looks like it'll be the easiest. So I'm going to make kind of a triangle. I want it to kind of keep its slope. I might round it towards the bottom so that the plastic doesn't have to mold around. So we'll start right here, and I'm going to start with a cube. I'm not going to worry about making sure its measurements are correct, like it's this amount of size by this amount of size. All I really need to worry about is from the top. That's not the top. All I really need to worry about is, we'll put down a plane so that I know that I'm going to fit on my print bed. I'm hoping I can print just 3 parts and fit all 3 parts on the print bed. There's no guarantees for that. I might have to split it up and glue them together. So I'll make this guy 150. So this is my print bed, and I think I'm going to be chunking these up into 4 parts. Or 6 parts. Yeah. 2 for each side, 2 for the front. I'd 6. So whatever I do make will kind of fit, well, maybe I might, I might just be able to fit the one part. No, I'll make it into a couple. Who knows what will happen. I'm going to go ahead and save before I get started any further, because that is important to do, is to save. Save again. Very important. And we'll call this B, because this is for the B helmet, which is the one I have, but everyone else will be getting the A helmet. Unless demand is high for the B, which I doubt it will be. So I'm going to actually work from one side first. I'm not going to get all the way into the corner because I want this thing to sit flat. I'll move into vertex mode and I'll make my slope. And I also want to use the least amount of plastic possible, which I hope will work out for me. So that's kind of the general shape. Because it's a rounded shape, it's going to take me a little while to get this perfect. But it shouldn't take that long. I'm going to grab this corner here, I'm going to pull it out to the edge. That gets me that. Pull this corner, I'm going to look at the front. I'm actually going to hide what I'm looking at. Ooh, fun. So I can see what I'm doing. So this part here is going to move here. And I think this will move down here. And this is my flat edge, which I'm going to line up with the grid. Because this edge here will be hollow, because I will mirror it to the other side. So I only need to design 3 parts, or actually 2 parts, because everything else gets mirrored. So once we have our slope, then we can kind of smooth it out. It doesn't need to be perfect, because again, this part's not going to be used for anything other than just a mold, and it just needs to keep the plastic from being destroyed in the vacuum former. That. Look at the slope. Get this part a little bit closer. Like that. So I do want this kind of a sharp edge on the front, at least so I know where my the actual visor is. This is just to support the plastic and keep it from collapsing. So again, this doesn't need to look perfect. It's just to fix the failed vacuum forming attempt yesterday, or first vacuum forming attempt. I've never done it before, and I thought it went kind of well. I'll add some more vertices in here in a second. That might actually be too sharp of a bend. Then again, the part itself, I'll cut to my camera here. So the part itself, it's gonna get light on that. So the edge on here isn't really sharp. I don't think I'm going to get my camera to focus. Yeah. So this edge here is kind of rounded, but I can file that down with some sandpaper, and that should solve the problem. So I won't get too worried about that front edge, and this is the front of the visor that we're working on. So I'll probably sand this down. I doubt it'll tear plastic. I'm getting 2mm plastic, so it shouldn't be a problem. I'm going to turn off that smooth cut. It doesn't work. So, oops. Let's get this as close as I can get it. I'll add some more vertices. I'm not going to worry about rounding it off or getting fancy with it. Oops. loop out here. I'll add some faces, so we'll split polygon and just follow some sort of modeling code that people use. Try to keep good geometry. So, basic shape. I apologize for going through the ground plane so many times. Wow, I have a glitchy mouse. Wow, I'm just gonna hide it. So, I won't have the plastic protrude this much because that is a lot of plastic to print. And I'm cheap, so I don't want to use that much plastic. But that's going to be my front shape to keep the front from popping. The biggest culprit was the side panel. Did I minimize it? Where'd it go? Oh, yeah, it's right here. So the side here is where I had the biggest problem. The front wasn't really an issue because I think this popped before the front did. Or the front didn't even pop. It popped before it even get down far enough. So panels are more important. And I was told by a few people that for me that this is something that I need to work on and make sure my molds are not shells and that they're solid pieces. Especially if I ever do get this vacuum formed by a company. I will leave a little bit for actual like structural support because I'll probably do a pretty large honeycomb for this. Because again, it doesn't need to be perfect. So I'll move this vertex out because it is inside the geometry. And I'll add another mesh or do edge loop. Probably when I glue this together, I won't worry about adding a groove. The one I upload, I just want to get this working so that I can say that it works. But the one that I upload to Thingiverse will have a little bit more design to it. It won't just be this cheap chintzy part. It'll look a little bit better and be a little bit easier to attach. I might actually just extend the front of this so that when you print these parts, they're all shaped together. So it works better. Another edge loop here. Didn't like doing that. Why? Because it's not an edge loop. So we'll do spin face. So do that. So it looks pretty good to me. This is a significant amount of plastic, if I do say so. That could be annoying later. I'll pull the front in. Probably don't need that much of a slope. Oops. A little bit closer for everybody. It is YouTube. Flatten these out. And if anyone has any questions about anything I'm doing for this helmet, please feel free to comment or use the chat on the live stream. If you're not watching this live, please comment below. I do respond to comments. I try to respond to them as quickly as possible. But you know, I don't really ignore people. If you ask a question you may think is dumb, there are no dumb questions. I'm sure everyone's heard that before, but I don't believe it, especially being a person that teaches people how to use. Occasionally, if you don't know, you just ask. Doesn't hurt. So I think that's pretty good. I'm going to delete this face, because this is where the other side will go, and we'll see what it looks like. So we'll duplicate, and I think yeah, it is. And negative the X. So that's kind of what the front will look like. I'll duplicate the other so we can see. So this is the front of the visor. That's the piece that's going to go in front to kind of support plastic from getting sucked in and bubbling inside the shell. This sharp edge will give me a definite line of where the visor ends, so I know where to cut the part out. Because I 3D printed everything and didn't like model it with the clay or anything, especially for the visor and the helmet separately, I don't have to worry about cutting off too much plastic, because the one that I did finish on the, or kind of finish, fits perfectly. It lines up in all the places. The pieces that I'm going to upload for the shell, or the frame of the helmet, do have lips, so you can put a nice bead of glue around the entire outside and then glue the frame in and tape it on and do what you normally do for Daft Punk helmets if you were to buy one. So if anyone's done this before and they're just like to try something different, 3D print one, it is set up the same way. So I'm happy with this. It'll print kind of funky just because there's not really a whole lot of geometry to it. It's not smoothed out. The final version will be smoothed out and look a little bit prettier, or look like it's a part like this one does, nice and smooth. And this has a lot of tessellation to it, so it's smoothed out. It's not, so we will see a lot of these polygons in the object. So let's get started on the back parts. If anyone can't tell by now, this is going to be a very short video because there's not a lot of parts to do. So we'll show all. We'll hide our ground plane again. So now I'm going to do 2 parts here, and it'll determine based on how big my print bed is. So I don't think I'll be able to print it diagonally and fit it, but I might. It'd be awesome if I didn't have to print more than one. And now 150 millimeters by 150 millimeters is the maximum size for my bed, but I usually try to print things inside of that because there are there's the raft, and then there's the oh, I forget what it's called. So slicer configure. So there is it's not under support. I'm not updating right now. Brim is what I was looking for. So there's 5 layers of brim that I put on there just to kind of give it a nice base to stick to the print bed and not pop off. And that helps with ABS because ABS tends to warp as it cools, and if you don't get if the part's really large, it will warp more than a smaller part or a flat part. So I will probably split this up in 2 parts, but I'll design it so that 2 parts can fit in the same bed area. So I'll try to make them a little less than 120 long on both sides, which shouldn't be a problem because this whole span here is half of that is will fit on the print bed. So you'll be able to print each side on a 6x6. If you got a bigger printer like 12x12, you could probably print at a time. Let alone you could probably print the whole helmet. But that's not the point of my designs. So we'll start with these sides much straight. This part will be kind of perpendicular to the ground. It won't be angled like the one up there. It will, towards the bottom, kind of taper out and then smooth out. I will do the same with this one. I will kind of bend it so that it's got a curve at the bottom rather than just a straight edge, right angle to the ground. Same thing with this one. So I'll put in a rectangle and we'll shape it to the size. So go into my side view. And we'll pull a rectangle. And I'll go to about there. Because the plastic's thick enough that it won't, it shouldn't have a problem there. I'll just extrude that out a little bit. I'm going to add some edges to this automatically. Well, it's still a cube. And width. No, it's height, depth. So these will be the vertices that I'll pull up to fit that curve. So we'll go from there. So this first I'll zoom in. And we'll pull it up to there. This one on the end I'm going to pull in because, again, I'm not going to go into these corners. I'll leave the corners open because the plastic is going to be too thick to have any bubble gum effects. Basically, when you blow a bubble, it's not going to get stuck here and blow into the side of the shell, which it shouldn't. If anyone's vacuum formed before, please tell me I'm wrong, because I honestly don't know. I've never done this before. Well, I've done it once, and this is just my theory, is that it's happened because these holes existed. So pull these up. They just need to meet the general shape. I'll use some 2-part epoxy to, basically you can get it at Ace Hardware or wherever hardware store you have in your area. I like it because it's meant for fixing like lawn furniture that's made out of ABS plastic or other electronics, radio or whatever, TV, something else you broke that's made out of ABS. A lot of things are made out of ABS plastic, and it's cheap. It's like $3, and you can put together almost half of the Daft Punk helmet can go together with a tube, and it be a little more user friendly than ABS paste, because sometimes you just don't want extremely flammable chemicals in your house, and I don't. I have it, but I don't use it inside my house. Use it outside. So that's going to be our part. Kind of looks like a roller coaster. Gets the top, goes down. Go to our side view, and we'll get an idea what it looks like. So there's our part. I will move it over so that it lines up. My computer runs really slow when I'm streaming. I might have to stream less and just make videos more. So it does angle a little. Probably just fix that just by rotating it a little bit. And slide it out. Actually, no, we're not going to rotate it. I'm just going to bend it, because otherwise then my vertices won't be a side view. So I'll go into vertex mode. We'll pull this in like that. And they're going to stick out a little bit because I want that very defined line, so that when the plastic goes around this, it will show up very easily and I can cut it. And if it's wrong, I can just 3D print it or 3D print a new one that doesn't have this big of a lip. So hopefully, if this goes well on Saturday, and these parts work, I'll upload the rest of the helmet, and I'll hold off on the visor, because most people will probably print I'll upload this part of the visor and say, use at your own risk. Who knows? We'll see. I am doing this for free. So there's my part. It'll sit underneath the helmet. On the one side, it'll over the side that I can just put a little glob of epoxy on the inside and pretty much attach this to the mold. And then when the plastic goes around, I'll have a sharp edge. I'm actually going to push it in so that the plastic goes in rather than out. And this outside part, I'm going to drag out. So I'm going to get my edge. And there's my bottom edge. Yep. And I'm going to pull this out so that we have kind of a slope. Kind of like that. So it's a little kinder on the plastic as it comes down. Do that, and go back to my top view, and I'll adjust these sides here. Oops. There we go. And now it's going to start to get a little bit smoother. Okay, I'm going to save because I keep forgetting. no. This is B. Wow, this is really hard on my computer. I have a Mac Pro, if anyone's wondering, so it's not the new one. It's a fairly old one. Got it 2008. So it's normally very, very fast and still a very good machine. But the graphics card is terrible, and I'm guessing it's using most of the graphics card to run Maya. Yeah, shit happens. So there's my side panel. I'll split it in half right down the middle, and because the inside is flat, you should be able to print these side by side on the printer and not have any problems. It'll probably be right about here. Yeah, it'll probably be because that's good half between the front and the back. Yeah. Perfect. I'm going to go ahead and put in some edge loops on here to smooth out the bottom. I could actually, I think if I bevel it, I'll have to put on another edge loop in there, yeah. So I'll do this. My edge. I'll flatten this out, lower it down. Flatten it out a little bit more. Lower it down. So there we go, that's pretty simple. When you vacuum form the plastic, it does pick up details. So I'm going to try and get this as smooth as possible, toss it, whatever I need to do, so that when I do it again, it's not showing any of these build lines, because it actually does pick up the build lines, which I didn't think it would do. So I will paint it and sand it, paint and sand, paint and sand, like you normally do to make anything smooth that's prop related. Basically anybody I've seen who does this stuff, they paint and sand, find little rough spots, sand them down, paint it again, and then you put on a nice gloss coat. So when the plastic goes on, it's gonna go on smooth. And if your plastic is clear, it'll come out clear, and it won't come out all foggy and ripply. Also, another good tip from what I've been reading is get some good heat-resistant plastic. Auto paint is. I see people use auto paint a lot. So this part, I would say, I'm happy with. It's not the best. I will go back and make it a little bit prettier. But it's Thingiverse, so I can keep uploading updated versions and say, this one works a little bit better for vacuum forming, blah, blah, blah. I probably will make more of these helmets and I suppose get them to the point where they can be chromed and sell them. So if anyone just wants a helmet, they can contact me at my website or through Facebook or Twitter, and we can set something up. I eventually have a store on my website where you can actually buy these things, but they'll be based on demand. So if I don't have any demand for them, I won't make a lot, and then if I suddenly get a bunch of demand, there'll be a waiting period to actually put them together. Excuse me. So we'll split this in half, and extract. And because these two pieces need to go next to each other fairly closely, I'm going to move into my side view, and I'm going to shorten one up a little bit because plastic does expand, and having something on top of the other line perfectly is not realistic in real life. There are gaps. most of the world is empty space because atoms are mostly gaps. So we'll add a little bit of millimeter gap. Again, not an issue. The part that I'm actually using is the one that needs to be smooth. The parts here are to stop it from popping. And that should be good. Yeah, I shouldn't have a problem with that. I forgot to move my, so I'm gonna combine these again so they're one part. I was gonna move in my edge on the front so that, bam, just like that. So that when the plastic goes around, it curves in rather than out. So there we go. Should be good. As long as there's a defined line on where I need to cut my plastic, I'm happy. Yeah, that should be good. So we'll separate those. I'll hide everything else for a moment while I fill in the hole. Let's say fill hole. And I'll leave it like that. I'll use cleanup on it before I go and send it out to be 3D printed or turn into a STL, which I thought was stereolithography, but I was wrong. And for the life of me, I can't think of what it's actually supposed to be called. STL files are, yeah, I can't remember what it's called. I'll look it up later. But they're not stereolithography. That's actually a type of 3D printing, which I did not know. Even though, like, if I export this, export selection, it still says stereolithography, so that's why I thought it was stereolithography. But I looked it up, and stereolithography is a type of 3D printing that I think uses lasers. So I don't know why it's called an STL file, because the actual file is not supposed to be called that. Well, you can just Google it right now, but I'm streaming, so I'm not going to. So that's the side parts. These get duplicated. I'll group them and translate them, or scale them, one to the other side. So, oh man, I gotta save before we crash again. Oh, crash again. We haven't even crashed once. Oh. So here's the part. It's pretty simple. Basically, 180. 180. Should be able to print these both on a print bed with some other parts. Just fine. Just rotate it around 180 degrees. I will probably export them together and separately. So if you have a printer that's big enough to fit that, I mean, I think the maker these parts. I'll run a smooth command on them and keep the top of the shell open. I'll just delete these top vertices and then say smooth, and that'll make this nice and smooth for the parts that I upload. So these won't change much. This is just the general shape that I'm going to print to use it for my vacuum former. If they don't work well, I'll redesign them. So yeah, I'm going to delete these because I don't need that one over there. This front one, I'll seal up the hole on this side, but before I do that, I will move them over a little bit, because again, these parts are going to be up against another part of the exact same size, and plastic expands and contracts, and you can't have something occupying the same space as something else. Fill hole. Ta-da. Like I said, this wasn't going to take very long. It's only been 39 minutes live stream. I'm going to get started printing these tomorrow. I'll probably print a to see how they fit. Probably just these side pieces, because those are the biggest culprits. This front, I think, was probably be fine if these side panels didn't blow out like they did. So that's kind of the basic shape of it, or the final mold. I'll just duplicate everything so everyone can see what it looks like. So there we go. Turn off edge mode. So this is kind of the general shape. I'll smooth out these normals so it looks a little bit better. Apply and close. That's not that bad. So, yeah, I'm pretty happy with this mold. The A version, which is going to get uploaded, oh, that's weird. Takes about an inch off this bottom part here and moves everything up, and it looks a lot more accurate to the Daft Punk helmet. And that'll be the one that I do upload. Other than that, there's not really any big difference between that file and the one I'm designing for, so they should both print the same. I will print a version of it just to see how it prints and confirm that, yeah, it should slice fine, because all the parts that I upload should slice just fine. If there's any holes in them, I do not upload them. So if I can't get them to slice, I don't upload them. So if you say that you're going to, please let me know, because you shouldn't be, and I don't want someone to be struggling and pulling their hair out over trying to get a file to slice. Just send me a tweet, Facebook message, email, and tell me that, or message me on Thingiverse and say, there's a hole in this file and I really want to print this and I can't get to print. I will do my best to fix it and get it working again. But yeah, everything I upload, I try to make it the best I can get it at the time. And yeah, so there's the. I think that looks pretty good. I'm actually gonna export these and see what they look like on my 3D printing software, which is heated up. I'm actually gonna jump over and turn on the, because it is on, or the heat bed's on, but my extruder is not. Mainly because leaving your extruder on hot with ABS in there can burn the ABS. So I'll turn it on now, and I'm gonna raise it up and rehome it after it's heated up. Sometimes there's a little bit of plastic on the end of the extruder, which if you home your printer while the plastic is kind of hanging out of the bottom, it'll sit on top of it, and when you heat it up, it'll kind of smush out like a pancake and can stick. And I've had some issues where when it pulls off the heat bed, it makes a weird popping sound, which I'm sure it's fine for it. It's not going to hurt it. It's metal. But I've put a lot of work into my 3D printer and upgrading it and making it what it is now, and it runs really, really well for a wooden printer. I haven't had to tighten and calibrate every couple of months like people say wooden printers do. So I think it's just how you treat your printer. If you think, oh, it's just like a desktop printer, I should be able to hit print and it should print, you're wrong. All printers need calibration. Even if you buy a MakerBot, it still needs to be calibrated in some way. The monoprice printer, which is I might buy next, just because it's such a good deal and just see how it works, and people have been giving good reviews for it. Just because it has a bigger print platform than I have. I'll still design my stuff for 6x6 beds, just because that's as smallest as I think parts should go. Occasionally I might have a part that is bigger than that, and I will still upload a version of it that can be split in half. But the bigger I can make things, the bigger I will. But yeah, my PrinterBot LC has served me well. I think it was a very good investment. So that's heating up. We'll go back and we'll export these parts. So we'll save, and then we'll save again. And I'll call this print. So 71B print. This is how I know that the file has been printed. I'm going to hide my visor. Like that. Oh, right. So mine has its issues. Re-add that to the visor. Not that it matters, because this is the print file. I usually never come back to this one unless I need to export it again. So we'll select our 3 files. We'll say mesh, cleanup, and it opens on my other screen. So this is what it looks like. It's just, I've showed this before. It's just the different settings that the automated cleanup function will add. These are the ones that I chose. You can choose different ones. Apply to selected objects will apply it to the objects you have selected, whereas apply it to all the polygon objects. You can select certain areas of your object and apply a cleanup command to it. This is helpful because sometimes you want to keep the geometry the way it is in certain spots, but fix a mess that you've created. So I'll apply cleanup, and there we go. So it's tessellated a lot of it, because that's the way my settings are set up. What needs to be tessellated, the rest can stay quads instead of triangles. Back to object mode. So we'll export this selection, and we'll move to my STL folder and Guy Man, and we'll call this the visor. Say, which one do I have selected? The back one. So say visor side back port top. I'm gonna call the next one the middle and the other one the bottom. So I hope that makes sense. I mean, once you print them all up, it should make sense. I don't have any parts that are confusing at all in how they hook up. So we'll export that one with the G key on the next part, and we'll put this one in the mid, and export this one as or bot, just to keep as small as text as possible. I've downloaded some parts off Thingiverse that are just freaking. So there's I might remake this one because that is plastic. I don't think it needs to be that much plastic. So I will now jump over to Finder. So here, STL, Guy Man, and we'll do the top. So I forgot a step. So I've mentioned in previous videos that the Z space in here, basically front to back, to my little triangles. There we go. So blue is the Z space and green is the Y space. Z is up and Y is back to front. So these need to be rotated before they can be exported, and they need to be rotated around the X-axis. Export, and we'll do that again because I am an idiot sometimes. So we'll say top, we'll say export, we'll say yes because that's the one that's in the printer software right now. Mid, export, yes, and the top, export, yes. And we jump back to repetir and say yes. It'll flatten itself out. Ta-da, look at that. So you should be able to fit two of these fronts in a print bed. So copy one, and I know, it's whatever. And I'll, it needs to be mirrored first because it's the other side. So turn off lock aspect ratio. Whoa. And this one will go here. And I'll rotate this one 180. We'll do 140. 160. Yeah, there we go. We'll put the other one at, I think 20. Yeah. So there you go. And you can fit the entire front pieces in the print bed. I'll run slice on it. We'll see how fast it goes. Sometimes it goes fast. Sometimes it goes freakishly slow. And I have to come back 10 minutes later. And it's really, really slow for the... Oh, there they go. And I occasionally get this problem. Some people might also mirror inside the program, and the mirror disappears. This takes 2 hours and 14 minutes to print. So I'm going to try and reduce the plastic before I print this one. Also because it has this it's going to have a hard time printing that well. There's a lot of weird oddities going on. So this isn't a very well-designed part, and I will say that right now, it's not a well-designed part. Let me fix my mic right there. This is a very quick part designed to fit a need, and I am going to rework it. Not in this video. I want to end in 10 minutes because I don't want to go over an hour. Future videos will probably be a little bit. I might actually just record myself doing them and then upload them, because that's what other people do, and they'll make them a little bit shorter so they're bite-sized, and you can watch them really quickly and then come back to them later. Remove this part, and I'm going to try printing the side panels because those are the ones I really. So I'm going to go over here and we'll do the top. What's going on here? G, top, yes, yes. There you go. For some reason my Mac equivalent just activated. So there you go. Look at that. Both fit in there. I gotta probably print all 4 tomorrow. Look at that. So I just need to duplicate these. Copy. Yeah. And again, there we go. Derp. Okay, so there's my left and there's my rights. I don't think I'll be able to fit these in the bed. They'll probably print better if I just do the one side at a time. I'll try the 2 tonight and see how far they get. It is 9 o'clock. So they might finish around midnight. So stay tuned to my social networks. You may see a photo of them. We'll slice them. We'll see how long they're supposed to take. And if they even slice. So more complicated parts can sometimes slice really quickly or go really quick. These look like they might be quick. It's like watching paint dry. Hey, look at that. It's done. Ooh, those look nice. So I kind of like the low poly look. Some people have been uploading things to Thingiverse that have that low poly look. And the outside of these, you can see the poly. Designing a low poly look is actually easier than it's basically just not getting terribly detailed with any of it. And this is going to take 3 hours, so that's going to be 9, 10, 11, 12, 1. I'm not going to print both of them tonight. I kind of want to sleep, and 3D printers are loud, so I'm going to print one because should print fairly quickly. So I'll slice just the one. We'll go back to my G code. We can see it update. So yeah, pretty smooth. This flat face will glue together really well, even with ABS. And 3 minutes. So look at that. I'm going to go ahead and print this and see how it fits in the helmet. So again, thanks for watching. Some people watched the live stream, and again, thank you. Without you, I would think I'd be talking to no one. And not that I care, because people will watch this after it goes up online, but it is nice to know that some people have watched this video. Again, like, comment, subscribe, find me on Facebook, Twitter, whatever social network you'd like to use. Not on Google Plus as much as I would like to be, but I'm on Facebook and Twitter pretty much equally. The link to download this helmet will be in the description. As soon as it's done, as soon as it's uploaded, I will put the links to everything in here. So again, thanks for watching. Please like, subscribe, comment. Thank you for watching. Goodbye.